Okay, so this is section 11-6. All right, so Isabel said that she would like to start us out by guessing how to do this. So what are we supposed to do? I'm going to repeat what you're saying so the microphone can hear.
I'm just guessing, but I just wanted to guess. Would it be 8 radical 7?
Right. Why do you say that?
Because the radicals are the same, so you can combine.
The radicals are the same, and they're like a variable, so we can combine the like variables. So radical 3 and radical 5 makes radical 8.
Wait, what?
I'm sorry, radical 8. I'm sorry, 8 radical 7. Okay. Now, number 2. Number 2. Sully, what do you say?
I think it's 4 radical 3.
4 radical 3. Okay. I'm having technical difficulties. Shh. Okay, number 3, please. Tulia. I can't hear you. And that's because we're adding 2 radical 5, 1 radical 5, and negative 7 radical 5. So 3 radical 5s minus 7 radical 5s is what? Negative 4 radical 5. That's correct. Okay, and the last one, why don't you all do it on your paper? Shh. All right, Charlie, why don't you help me out with this? Explain.
Okay, so 6 radical 2 and radical 2
Yeah.
have radical 2's, but radical 6 isn't radical 2, so you can't subtract that.
Okay.
So it would be, because that's a 1, so it would be 5
5 radical 2
minus 2 radical 6.
minus 2 radical 6, because they're unlike terms, so we can't combine them. Just don't forget about that. Even though it says negative radical 2, it's really negative 1 radical 2. Okay? And there's no perfect square in radical 6, so we just stop. Okay, so just talking about like radicals versus unlike radicals, just like variables. Like radicals can be combined. Unlike radicals can't be combined. Here's what they look like. Here's what they don't look like. Here's what they look like when they're unlike. Now, notice when I have 6 minus 2, I can't, it's not just a 2, it's a 2 radical 6. So I can't subtract that. And here, notice radical 10 and radical 10 make 2 radical 10s. We don't add inside. We leave the variable alone, or the radical alone. 1 radical 5, 5 radical 2. Can't be combined. And be careful with these. It looks like they're different, but when you break 20 down, you can see that they're both radical 5s. So 2 radical 5 minus 1 radical 5 would make radical 5.
You have to break it down.
Yes, you have to break it down to see what it really is before you can see if you can combine. Okay, so 32, what does it break down to? What? 6.
Oh, wait, no, sorry.
32.
8 and 4.
32 breaks down to what?
8 and 4.
8 and 4.
Go bigger. 2 and 16. So, radical 2, radical 16 times radical 2 is 4 radical 2. Plus 18 breaks down to 9 times radical 2. So that becomes plus 3 radical 2. And what does that simplify to?
7 radical 2.
7 radical 2. Okay, questions? All right, erasing.
Can we try one out?
Of course. All right, so why don't you try number 1? Pause the recording and try the next 4 problems on your own. All right, so let's check some of our answers. Number 1. Number 1, Anna.
Number 1, I got.
I don't want an answer. Tell me what to do.
Okay, so for the radical 12, I simplified it down to radical 4 times radical 3.
Radical 4, radical 3, and what does that simplify to?
2 radical 3.
2 radical 3.
And then for 27, I simplified it down to radical 3 times radical 9.
Radical 9 times radical 3, and we get,
3 radical 3.
and what does that simplify to?
It simplifies to radical 3.
Negative.
No, wait, what? Negative radical.
Negative 1 radical 3, or you could write negative radical 3. Okay, next one. Is this the one you both were on and you had different answers?
Yeah.
Okay, so Daniela, how do I break down 72?
I did 8 times 9.
I'd do bigger. What's bigger? Ashley? Yeah, square root of 36 times square root of 2.
Okay, then you do 4 times 2 for 8.
Okay, minus, let's finish this one. 36 radical 2. What can I do to simplify this side?
6.
6 radical 2. Now radical 8, Harper.
You can simplify that with 4 times 2.
Radical 4 times radical 2, and we end up with, okay, and so what do I end up with?
4 radical 2.
4. 6 minus 2 is 4, and I'm left with radical 2.
I got that answer, I just did it with 8.
It's okay, 8 and 9 works, it just takes a little longer.
Wait.
Because once you get the 8, there's still another perfect square in there.
Oh.
Right? Because if I, let me erase it and I'll do it that way. So I'll do it that way. It just would have taken one more line. That's it. That's why I chose the bigger perfect square. 72 is made up of square root of 9 times the square root of 8 minus the square root of 8. So square root of 9 is made up of 3 times 4 radical 2. Do you understand?
Okay.
Minus radical 4 radical 2. Now I have 3 times 2 radical 2 minus 2 radical 2. And so this makes 6 radical 2 minus 2 radical 2, and it's 4 radical 2. So that works too. I just choose the bigger square root.
So do you always use the bigger
It helps. It's less steps. Okay. Who wants to help me with number 3, please? Okay, Andres? Break it down. I'm sorry, Andre.
For 75, I broke it down to 9 and 5.
For number 3,
Yeah. 75.
you're breaking it down to 9 and 5?
Oh, never mind.
Yeah.
I thought it was 45.
Okay, so how do I break 75 down?
You can break it down to the square root of 25 times the square root of 3.
Good. And that becomes?
5 radical 3.
Okay. 48 gets broken down. 48 gets broken down. How, Armin?
Radical 16 and radical 3.
Yep. And that becomes what?
4 radical 3.
4 radical 3. And then I have a plus radical 3. Plus radical 3. Now how many radical 3s is that?
1.
1 radical 3. So altogether, actually, let me switch that color. 1 radical 3.
So it's 2.
So altogether, 5 minus 4 is 1, and 1 radical 3 makes 2 radical 3's. Okay? Did you do number 4? How many people completed number 4? Okay, so let's do number 4. Someone I haven't heard from. Maddie, how would you break down 90?
9 and 10.
Perfect. Radical 9 times radical 10. And what does that simplify to?
3 is radical 10.
Good. Next one, minus the 40. How do I break that down? Anaya.
4 times 10.
4, square root of 4 times the square root of 10. And what does that simplify to?
2 square root of 10.
Okay, and then 20. This is sneaky. Lewis.
Wouldn't it just be radical 4 and radical 5?
Plus radical 4, radical 5. And we end up with
2 radical 5.
okay, and so what I end up with is, now I can combine, and what do we get? Yes,
You get a radical 10 plus 2 radical 5.
plus 2 radical 5.
Wait. Why wouldn't you just do 2 times 10?
Because when you do the 2 times 10, it's radical 2 times 10, not, look up here,
Oh, you
look up
can't-
here, not 2, right? Look, this is a 2 radical 10. If I were breaking that down, I would have to do radical 2 times radical 10, and that's different than 2 radical 10. Yes.
Why couldn't you make all of their like the radicals by 2, and then just like 45 radical 2 for 90 and all that?
20's on a
Because you're not pulling out any perfect squares.
Oh.
Our goal, so the question was, why can't we break down 90 into 45 times 2? We can break it down like that, but my goal is to pull out the perfect squares. All right, I'm erasing. Let's just hope I have all the same answers. All right, so now we have some variables. Assume all variables are non-negatives, okay? So 50 breaks down.
25 times 2.
25 times 2. Good, Charlie. So we're doing the radical 25 times radical 2. And I have times radical y squared. Okay? Oops. Minus radical 4 times radical 2 times radical y squared. Okay, the square root of 25 is 5. Can we take the square root of 2? And what's the square root of y squared? 5y. But I'm left with a radical 2. Minus 2 2y radical 2. So altogether, what does that make when I combine my like terms?
3y radical 2.
Beautiful. 3y radical 2.
Wait, why is it 5y?
Because I pulled out the square root
Oh,
of 25 and of the y squared. Okay? All right, let's try another. You want to do it on your own?
Yes.
Number 6, go quick. Go fast. All right, so let's check our work. Okay? I'm going to just put it up here because I have a couple more slides I want to show you. Shh. So, on number 6, we're breaking it down by 4 times 3x to the 4th. We can take out a 4, a 2 out of the 4, and an x squared out of the x to the 4th. And then I'm left with radical 3. I can take out a 3 and an x squared, and I'm left with a radical 3. And we end up with 5x squared, radical 3.
Yay.
Okay, let's take a look at this one here. So when I'm down here, if I have something like this, I can't combine because these are unlike terms. Do you understand? Look at these terms. 1 and 5x are unlike terms, but their radicals are the same. So here's how I write it. 1 plus 5x times the radical 5x. Is that clear? Okay, I need to erase. Okay, in this case, what do I have to do first before I get started? What do you think I can do in the first term? Charlie?
Pull out a 9.
Factor. Factor inside. Factor inside. I can factor that, and so I'm pulling out a 9. Now, I can take the square root of 9, but not x squared plus 1. Do you understand?
3 times,
The radical x squared minus 1.
I know, it's minus.
And then I can also, what can we pull out of this one?
X squared.
And I'm left with x squared plus 1. So now what I have, because they're alike on the inside, I just do my 3 plus my x, and inside the radical, it's all going to be all times x squared plus 1. Does that make sense? One more slide.
Yeah, okay, I got it.
2 more slides. All right, got to move on. Shh. So, we're doing the same thing. I got to show you one more with fractions. All right, so let's look at this. Fractions, right? Turn the other one into a fraction too. Let's put it over 1. Okay? And now, when I'm adding and subtracting, first of all, we have 2 things. Allie, pay attention. Sorry. Okay. We have 2 things here. We have a denominator of radical 5, a denominator that I got to get rid of because I can't have a radical in the denominator. So I got to clear that, and then I have to find a common denominator. So first clear the radical by multiplying by radical 5 over radical 5. Okay, now what do I do to get a common denominator?
Multiply by 5.
The other fraction by 5 over 5. Okay, we're multiplying the other fraction by 5 over 5. And now what I get is 5 radical 5 over 5 minus 1 radical 5 over 5. And so what do we get? 4 radical 5 over 5. Okay? Pause the recording and do the next problem. Now check your work. Okay, we have to get rid of our radicals in the bottom. So for the first fraction, what am I going to multiply it by to get rid of the radical?
3.
Radical 3 over radical 3. And the second one,
6 over 6.
right, radical 6 over 6. And then I'm going to to clear my denominator, multiply both sides to get a common denominator of 6. And I end up with 3 radical 6 over 6. Okay, so now, because I have a common factor in the numerator and denominator, I'm going to simplify, divide the numerator by 3, divide that denominator by 3, I'm left with a 2, non-radicals with non-radicals, and so what I'm left with is radical 6 over 2. That's the final simplified answer. That's the lesson.